Assalamualaikum warahmatullahi wabarakatuh, and a very good day to our lecturer, Ms. FARAHA. In this video, our group will be explaining our solution for assignment 3, MAT565, Advanced Differential Equations. So before we start, I would like to introduce our group members that consists of DIYANAH binti ROSLI, Adha bin DZAKI, and me, KHAIRUNNISA binti HAZRI. So in this video, we'll be talking about the answers for question A, B, and C. Alright, so I will start to explain about our assignment question, which was given by the lecturer, and the question is about the Fourier series, which the function is defined as pi x from -1 to 1, and another function of fx is pi x minus 3 power of 2 over 4, the value of x from 1 until 3. So the first question is question A, that asks to sketch the graph of fx in the interval of -5 until 3. Before we sketch the graph, we have to plot the graph by finding the coordinations of x and y from the equations given. So the first equation given is fx equals to pi x from -1 until 1. Therefore, when fx is pi, the graph will have a straight horizontal line at -1 pi until 1 pi. Next, we will find the coordination from second equation, which are fx equals to pi x minus 3 power of 2 over 4, and x values from 1 until 3. So we have to substitute the value of x with 1, 2, and 3, so that we will get the coordinations. There are 1 pi, 2 pi over 2, and 3, 0. Therefore, the graph will become a curvy line from the horizontal line at fx axis until at the x-axis. Not to forget, the question asks for the interval -5 to 3, so we will have to sketch the graph for 4 periods. Thus, another graph will sketch from -5 until -1 at x-axis. As a result, our graph has period of 4 and the L value is 2, and this function is neither odd nor even function. Next, we will also continue with the solution for question B. Question B asks to find its corresponding Fourier series. Hence, we will be using the general equation to find its corresponding Fourier series. To start off, we have to find the A node. As shown in the figure, we solve the A node by using the full range formula 1 over L integrate -L to L fx dx, and the L value that we have found before is 2. And the equation of fx were given as well, so we just sub in those values into the formula. Hence, we got the value of A node is 3 pi over 2. Next, we will have to find the value of AN. We also solve by using the full range formula for AN, 1 over L integrate -L to L fx cos n pi x over L dx. And as shown in the figure, the AN has two different equations. So, we decided to calculate AN separately to avoid mistakes. Therefore, we had to solve the AN one by one, as the first part of AN is pi over 2 integrate from -1 to 1 cos n pi x over 2 dx, and the second part of AN is pi over 8 integrate from 1 to 3 in bracket x cubed minus 6x squared plus 9x cos n pi x over 2 dx. Thus, for the first part, we have solved by integrating the cos n pi x over 2, and we got as sin n pi over 2 minus sin -n pi over 2. And finally, we got the value for the first part of AN is 2 over n sin n pi over 2. For the second part of AN is we have calculated by integrating the functions using the tabular method. Therefore, our second part of AN we have is negative sin n pi over 2 minus 6 sin n pi over 2 over n cubed pi square minus 6 sin 3 n pi over 2 over n cubed pi square plus 12 cos n pi over 2 over n power of 4 pi cubed minus 12 cos 3 n pi over 2 over n power of 4 pi cubed. Then, we have to combine these two parts into one to form the value of AN. Thus, we got the value for AN is 1 over n sin n pi over 2 minus 6 over n cubed pi square sin 3 n pi over 2 plus sin n pi over 2 minus 12 n power of 4 pi cubed cos 3 and pi over 2 minus cos n pi over 2.
Thank you, KHAIRUNNISA, for the explanation on how to find the A0 and AN. Now, I'm going to show you how we can find our Bn for the Fourier series. The given general formula for Bn is 1 over L integrate from negative L until L for the function of x multiplied with sine and pi x over L. So, in this question, we have a piecewise function where the first function is pi and the second function is pi x multiplied with x minus 3 to the power of 2 over 4. Then, by substituting both of these functions and our L value, which is 2, into the Bn general formula, we are going to be able to solve for it. Okay, since our Bn equation now is too long, we split it into two parts to make it easier to calculate. The first part is going to be our first function, whereas the second function is going to be the second part. Now, for the first part, we first took out our constant pi over 2 from the equation to make the integration easier. Then, we integrate sine n pi x over 2 and we get negative 2 cos n pi x over 2 over n pi. Then, by insert the limit from negative 1 until 1, we get cos n pi over 2 minus cos in the bracket negative n pi over 2. And we know from the even and odd identities states that the cosine of a negative angle is equal to the corresponding positive angle of cosine. In other words, the value of cosine remains the same when the angle is flipped. Then, by applying this identity into our equation, we get cos n pi over 2 minus cos n pi over 2, which is 0. So, that's it for our first part. Moving on for the second part, this is an integration of a product of two functions where we have an algebra function multiplied with a trigonal function. And of course, we can use any integration method that we want, but I recommend to use the tabular method since it is much simpler. Then by following the tabular method, we first need to differentiate our algebra function until we get 0, and then we integrate our trigonal function. And now we already have a new equation with a limit from 1 until 3. Next, by inserting our limit from 1 until 3 into our new equation, we then able to solve for our second part of the Bn. Finally, we combine our first part with the second part of our Bn, but previously, we know that our first part value is 0, so then it means that our Bn value is equal to the second part that we get just now. And after determining the values of A0, AN, and Bn, we can now proceed to the final step of solving question B by substituting these three values into the general Fourier series equation. By doing so, we will obtain the final answer for question B. Now, my friend Diana will take over for the question C. Thank you.
Assalamualaikum and very good day. My name is Diyanah binti ROSLI and I'm about to explain the solution for question C. The question asks to determine the Fourier series for fx in the standard form until the second harmonic. From the question, the value for xr and yr is already given along with the value of a2 and b1. The first step is we need to construct a table that consists of xr, yr cos xr, yr sin xr, yr cos 2xr, and yr sin 2xr. After filling in all the required value for each column and row, next we need to sum up the value for each column. When the table is completely constructed, now we can find each value in the standard form equation. Before we go to the next step, the standard form equation for second harmonic is fx equal to c0 plus c1 sin x plus alpha 1 plus c2 sin 2x plus alpha 2. It stops until the c2 sin 2x alpha 2 because the question only needs until the second harmonic. To find the c0, we require to find the a0. The a0 formula is 1 over 6 the summation times the summation of yr. After we find the a0, now we can find the c0, which is 1 over 2 times a0. After finding the value for c0, now we can find the value for c1. To find c1, it requires us to find the value for a1 and b1. The a1 formula is 1 over 6 times the summation of yr cos xr. After finding the value for a1, next we can find the value for b1. The formula for finding the value for b1 is 1 over 6 times the summation of yr sin xr. Now we already have the value for A1 and B1, so we can find the value for C1. The formula for C1 is square root A1 square plus B1 square. After finding the C1, next we have to find the alpha 1 by using the formula tan inverse A1 over B1. We get the value for A1 and B1 is negative, so the angle will be at the third quadrant. The next value we have to find is the C2. To find the C2, we have to find the value for A2 and B2. To find A2, the formula to find A2 is 1 over 6 times the summation of YR cos 2XR. And to find the B2, the formula is 1 over 6 times the summation of YR sin 2XR. After we get the both value for A2 and B2, now we can find the value for C2. The formula for C2 is square root A2 square plus B2 square. To find the alpha 2, we use the formula tan inverse A2 over B2. We get the value of A2 is positive and the value for B2 is negative, so the angle will be at second quadrant. The final step, after we get all the value for C0, C1, alpha 1, C2, and alpha 2, we can insert all the value in the standard form equation. And that is all for me. Thank you.
That's all from our group. Thank you.